Hello, everyone. Welcome to this talk on modern Java app development in the cloud. So we're going to talk to you today about lots of cool cloud Java-related technologies. So welcome, and it's a pleasure to be here. It's an honor to be back at GeeCON. My name is Mats. I work in a Norwegian consultancy company called Kompetas, along with Rustam. I'm a Java developer, currently doing mostly Kotlin stuff, but in the cloud. And Rustam, who are you?
Yes, my name is, like Mats said, my name is Rustam. I work in the same company together with Mats. I work mostly with Java and cloud. I'm also a Java champion and Google Developer Expert for cloud as well. So today we want to talk to you about what it actually means to do a modern app Java development. I've been doing Java development professionally for, 17 years or so, and things have been changing quite a bit. So now doing Java development now and 17 years ago, it's a different kind of story. So we want to talk a little bit more about that. To do that, we kind of thought how to present it in a good way. And the way of doing that, well, obviously we all, as developers, we write code. And we write code, well, I guess we can say that all of us do it for fun, right? Who's doing it for fun? Yeah, I see some hands, like most of the hands. Yeah, exactly. But I mean, the truth is probably it's not really only for fun. We actually want to make it available for people. That's the kind of part of the fun. Actually, I mean, if you ask me, at least. So the idea is we write a little bit of code. We want to put it into production. How do you make it to production? What it actually means to put it into production, that part has changed quite a bit throughout the years. So,
yeah. So, but before we head further into that, let's just remember all of you that please ask questions. You should just line the URL up here. Use the code GeeCON. We're in room number 1, as you hopefully know. We got a couple of hoodies here, and we got lots of stickers. So, like whoever asks the most popular questions get a hoodie as well, with a cool technology called MicroProfile that we can talk about later on. So please ask questions. And we're now going to head into what we're going to talk about today. We're going to start with a simple application, like a really simple application to see that we have something that we want to make available for you as end users everywhere, somewhere in the cloud. So we started with we were thinking, what's the simplest application we could use that would actually make some sense? So we want an application that can give us 2 random words. Whenever you invoke the application, you get 2 random words, which can be used for things like multi-factor authentication or things like naming Docker containers.
Or naming your pets. It depends, really.
Yeah. So when you invoke it, you get a result like this.
Who wants to call their cat that? I mean, that works, right? Well, actually, the point is, it's a very, very simple application. That was the whole point of it. The application that you can just run. You run it, you get an adjective and a noun. And then you run it again. Well, that would be the name of your dog, I guess, or a hamster or something. But, it's the idea is simple, right? You have a URL, you have 2 words coming back at you. The logic, the code, it's super complicated. I mean, prepare yourselves. It's like really, really, really hard. It's like we had to compress it a lot to fit it into one screen. That's pretty much it. Yeah. I mean, it's a kind of truth with a little bit of modifications. It's a little bit more than that. There are a few helper methods and stuff. But basically, you read 2 files, you put it into some kind of data structure, and then you pick stuff at random. Simple as that. So technically it's, 4 lines of code with all the padding and all the, love you can give it. And, what do you do with that? Because what actually, any ideas? I mean, how do we make it available? How do we make it run? Anything? What do we learn at when we start object-oriented programming, our first Java class ever at university, school, whatever? How do you run this thing? Any suggestions? Main.
Exactly.
Thank you. We actually did this talk a few weeks ago, and then somebody suggested putting it on an application server as the first thing they do. I really want to go to that university. But, well, yes, main is actually what we're aiming for. And that's what you do, right? You slap on a main, you make it like put public static void main, string args, blah, blah, and then you run that thing, and you're happy. It works on your machine.
And that works perfectly fine, as long as you run it on your machine, only once. Like whenever you need to run it again, you rerun the entire application, and it stops between every invocation. Might be useful for some applications, but like I guess most of you work in projects or teams where that's not the regular case.
And I mean, it works really well for, you have a farm of hamsters or guinea pigs or, rabbits or something, because they multiply so fast. You need to run it on your machine. You generate names, you give names, you're happy. But, if you want to make it available for your friends that are really also into farming guinea pigs or something, you wanna make it available, and you have to make it run a bit more smoothly. So, there is a tiny little kind of hint on top there. Very tiny. I mean, especially on that screen, it's very tiny, huge. URL. So you want to make it available on some kind of web interface, HTTP, something that supports HTTP. In this case, it's localhost, but we'll get there. We'll get there soon. We'll replace that in a bit. But you want to make it available. You want to return a kind of data structure that we developer like. And probably the one that is a kind of RESTful, JSON-like stuff we love a lot, just after YAML, I guess. But, or not. But the idea is, how do you make it available? How do you make it as easy as possible without writing too much boilerplate? So this talk is going to be kind of opinionated. We had to pick a framework, we had to pick a platform to run it on, we had to pick a lot of things to make it work. That's how it works, right? When we develop something, it's not just a theoretical hand-waving kind of thing. You actually need to choose a bunch of things. So this is going to be an opinionated talk about an opinionated framework or like specification, but the idea will be the same no matter what you choose. You might go with, I don't know, not even it's a Java event, don't do that. But it could possibly be not even Java, but you can still do a lot of things of the same character. So in this case, we decided to go with Jakarta EE and MicroProfile. A quick show of hands. Jakarta EE, anyone? Who have heard of Jakarta EE? Okay, keep your hands. Java EE. Okay, a few more hands. So those of you who raised hands later, you could have done earlier, because it's kind of the same thing. It's just changed the name, it added some features, it added things, and so on.
Yeah, we could do like an entire talk on that, but we'll explain it to you in a second what it's about.
MicroProfile, anyone? Good.
Couple.
It's actually more and more hands every time we do this talk. It seems like there's some things are happening. We're not associated with them by any way, except for doing talks and using that technology, by the way. So that's being said. All right, let's do. What is that MicroProfile thing?
Yeah. So what is this MicroProfile thing? So the easy way to put it is that it's Jakarta EE for microservices, which might make sense for those of you who know already what Jakarta EE is about. But let's take one step back and give a short, brief introduction to Jakarta EE as well. And for those of you who don't know Jakarta EE, it's a set of specification, lots of different specs for things you typically need when you're developing a Java application. So it gives you things like dependency injection. It gives you a way to send, provide REST endpoints, to return parsed JSON objects. In several ways. You can do validation on your inputs, so that if you have a number as an input, it has to be positive, for instance, those kind of things called bean validation. There are lots of different specifications. We'll see them in a moment. But they provide most generic technology, most generic things you need when writing a Java application of kind of any size. So Jakarta EE can be great for microservices. It can be great for monoliths, whatever floats your boat. So MicroProfile, on the other hand, is intended, it's tailored into, well, you're writing microservices. And you are writing those microservices intended to be running in Docker containers or like Podman containers or whatever containers on Kubernetes. So it's tailored to that area. So Jakarta EE, on this slide you'll see some colored boxes and some gray boxes, which is what Jakarta EE 10, which is the newest version, is about. And you can see several other things I've talked about to the right here with CDI Lite, JSON binding, and so on. And you see lots of the gray boxes are things you might need, might not need. Things like mail, for instance, if you want to send emails from your application. There's a specification and a standard for that. And lots of other things as well.
And the important thing here is to note is that both Jakarta EE and MicroProfile that we'll be talking in a bit, in a second about, it both are specifications. So it's up to the others to actually implement it and to say, well, we are actually certified to support that. So there are certain ways of doing that. We're not going to talk about all that, but the point is this is a specification that needs to be implemented, and different vendors tend to do different implementations of that, and we'll see that. More of that in a second as well.
Yeah, but now, Rustam, maybe everyone wonders, why is this core profile in colors and the rest are gray?
That's a funny story. We can do the full enterprise kind of presentation. Excellent question. No, we're not going to do that. But it is actually a good question. But so the thing is, what happened was a lot of those things that you see on the screen there used to be a part of the whole MicroProfile specification as a separate boxes. Now things have changed a little bit. So what you can see here now, it used to be many more boxes on your left, where there would be many more boxes with the things we've seen here. Now they're all packaged into one little yellow box called Jakarta EE 10 core profile. So now you import that core profile and then you add more stuff on top of it to make it more microservice friendly. So, all the things that your typical microservice would need and all the things that you should look for in a library that you might be choosing. This is not really intended as a sales pitch for MicroProfile, but, look for things like REST client. You might need to use that because if you're consuming a REST service from another endpoint, you don't want to code all that HTTP calls and error handling and all that, and marshalling and unmarshalling and all that by hand. It's fun to do it once. It's not fun to debug that later. It's definitely not fun to write it 5 times in a row. Things like config, health. Some security stuff like JWT authentication and all this, metrics, fault tolerance, all this kind of things is really, really nice to have in your microservice.
Yeah, and I think we need to highlight just a couple of them, just shortly. So for those of you who are Kubernetes, how many of you have worked with Kubernetes in one way or another? Quite a few. Okay, great. Good. Then you might know that Kubernetes has the concept of Linus probe, readiness probe, and even also startup probe, like checking if your application is ready to accept traffic, if it's healthy and running and so on. MicroProfile Health especially is intended to be used as probes for Kubernetes. So that's what I meant when I earlier talked about that it's tailored for Kubernetes running applications. Config is also really interesting because there are ongoing discussions whether config should also be ported back to Jakarta EE or into Jakarta EE, back into it. But whenever you need to inject environment variables into your application, things like different URLs in different environments, different feature flags, all of these things, you can do that using MicroProfile config, which is also useful outside of pure microservices. So that's an ongoing discussion, which we could talk about for hours. I'm not going to do that because we got lots of more material to cover.
I mean, if you want to mention one more, probably Open API would be really great. It's because it's a really easy way to document your endpoints as well. But yeah, let's not go too much into that. Actually, there will be another talk after lunch, a short lightning talk, where I'll be going through more of those things in a bit more general, but also in specifically to MicroProfile as well. But that's a shameless plug. What is the MicroProfile official version, official slide? Well, that's that. That's basically copy-paste from the official slide deck with a little bit of a lot of words, and that's probably the most words you will see in one slide in this presentation. But it's an open source community specification, remember, for enterprise Java microservices. It's a community-driven by individuals, organizations, vendors, collaborators, open source foundation, working group that consists, that makes all that group is all the things that you see listed up there. And the idea is to bring microservices to enterprise Java community. And that was actually started when Java EE, back then Java EE was not really, there was not much happening around it, and this was a initiative to start something that will modernize enterprise Java into microservices and so on. Working group, corporate members, so that's what we mentioned, all these communities and companies and all that. You see a lot of here, you see a lot of big names here. You also see smaller companies, but also you see Java user groups. So Atlanta Java User Group, AJUG. iJUG is a German an umbrella of Java user groups. And also even smaller ones like Garden State Java user group as well.
Yeah, from New Jersey in the US. But what you see here is that there are user groups, there are small companies, and there are huge companies. And that is also like, for me as a developer, thinking, can I use this in production? It's like, okay, it's supported by IBM, Red Hat, Oracle, Microsoft. It's not going to end tomorrow. It's going to be available for quite some time. It's going to be well supported. Yeah, this is a safety net as the way of thinking as well. And also, it's part of the Eclipse Foundation. We said that in the previous slide. That means that there are guidelines for how do we develop MicroProfile further. How do you take actions? How do we make decisions? All these things is regulated through Eclipse Foundation.
All right. Why? Why do we choose MicroProfile? We talked a little bit already about these things, but if we have to summarize. Well, first of all, you want to write your logic, your code, because that part is fun. Boilerplate code, well, like I said, it's maybe fun once, maybe twice, but after a while it gets tedious. Oh, yet another HTTP client? Oh, okay. I'll do the same bugs again, and I'll debug them again, and then, there will be more. So it's easier to not to do that. It's easier to import the libraries that will do that. The other thing, it's lightweight. Lightweight in several meaning of that word. Because it's lightweight in a way how much stuff it pulls into your application, because if you would just add everything in Jakarta EE, it would be a really, really heavy application, because you have all those gray boxes that you saw earlier. All of them will be in your application. You'll be using a tiny little part of it. It's not a good idea for memory and footprint stuff. It's not really a good idea for security stuff. It's not a good idea for many, many reasons, for complexity, for all that. So that's the one thing. The other thing is that the memory and CPU usage and all that you want to make your application as small as and lightweight as possible as well.
Yep. And there's also a thing lightweight for you as a developer. As a developer, you make lots of choices every day. At least I do. Okay, should I use this technology, should I do it this way or that way? And MicroProfile is opinionated. You could see that it had JSON processing and JSON bindings as part of the MicroProfile specification. But JAX VS or web services with XML and SOAP and so on are not part of the specification. That means that MicroProfile, well, if you use MicroProfile, it's opinionated towards JSON. So that's not a choice you typically make unless you have some really specific needs.
Another thing is it's interchangeable, and that is a part of being a specification and others implementing it. It's not a really good idea to switch, engines on your racing car. We've heard that metaphor before, right? Switching your engine on your racing car while you're driving, but yeah, hey, you can. Again, don't do it just for fun. Sometimes you need to do that because you don't want to be vendor locked in. You want to be able to, something is not working in one application server, something is working better in the other one. Your company policy changes to go from one to another or something like that. That is more reasonable reasons for doing that kind of stuff. And that is here as well. So since it's a specification and it's you need to be certified to say, hey, we're compatible, then that also means that it will be quite smooth ride to change things. Normally, you need to change a few config files and you should be good, and a few like POM files if you're using Maven or similar technologies as well. Speaking of current implementations and ability to change things, this is what we have. We have Quarkus and Wildfly and Cumulus and OpenLiberty and Apache Tommy EE, which is the enterprise version of kind of based on Tomcat. Payara, we have a bunch of things. Helidon here as well. So yeah, this is implementations that officially support it to some extent, mostly full extent.
And that's great, like, because if you choose to start over one of them and figure out for some reason I need to switch to another one, then you can do that. We'll see that later on, as Rustam just said. But like, okay, so where do we start? And there are several answers to that. Like the first one is you head to the starter. There's a given like a MicroProfile starter for getting started with MicroProfile projects, obviously, which you can find at start.microprofile.io. Quite similar to like starters you've maybe seen on other products, like Spring Initializer, for instance.
Those kind of things keep on popping up, and they are around and for different projects and for different frameworks. And here you can see also vendor-specific ones that have been created as well. So OpenLiberty has one, Quarkus has one for all Quarkus things, but amongst the other things, you can actually pick MicroProfile, as you can see there, and say, hey, I want to have that in my Quarkus application as well. Helidon has one. So yeah, the point is most of the vendors would have their own thing, and they would, since they support MicroProfile, it will be part of that thing. And it will be a little bit different because different vendors would support maybe different, they may be a little bit not synced in a time-wise in supporting different versions. So maybe newer Java version would be made available in one, but not the other yet. Or newer MicroProfile version would appear faster in one and not the other one, so on and so on. So you can actually shop and choose, and it's not just one place. You can actually pick and choose from different ones. Okay, so now we talked about running the code, and we thought that, okay, first we slap on a main method. Well, that's kind of cool, but it makes it available only for you. It's not that fun. You can't do JSON and all that. So we talked about how we can actually automatically add and slap on the REST interface and endpoints and generate JSON and all that without too much hassle. So now it works on my machine. What do we do? The old answer is,
well, let's ship your machine then.
Yeah. That's the old one. The new one is, we kind of like our machines, is that we put them into generic ones. So we, put it in a container. And we put a lot of things in containers, and sometimes we put things we shouldn't put in the containers, but let's don't talk about that. The point is you containerize your application, and containerizing your application actually means that that machine that you're going to be shipping is going to be a standard shape and size. You can actually put it on different things that support it. And it also means several things. So it means reproducibility in several ways. It means reproducible builds. So you can actually know that if it builds on one machine using the same kind of containers and architecture and everything, it will be the same on the other machine, most likely. It also means reproducible deployments. It also means that if you actually are able to deploy that on one thing, it will be also running on the other thing. And also meaning the platforms that it's running. So that's why we have at least two different ones. Here you have Docker, which is kind of the most common one that people know a lot about. But there's also things like Podman. So I am actually running all of my things on Podman just for fun. So I sometimes of the old habit, I write Docker something. So I actually created just an alias saying alias docker equals Podman, so I can actually do docker blah, 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 and press enter, but it still runs Podman in the background. So, it's interchangeable even in that way. So you can just create the alias on your bash profile file, and it mostly works. Even compose works, and, desktop and all those kind of things. So it's kind of fun.
Yeah.
But Dockerfile, right?
Yeah, Dockerfile, or maybe similar with other container technologies. So you make a Docker file like say, okay, I'm going to start from this base image, say, Alpine or Tamarin base image or whatever, and then you're going to do like, okay, I'm going to do this and this and this and this step, and towards the end you have your application running, like starting up. And then you can consider things like, well, the containers are caching the layers, so every new line in the Docker file is a new layer, which means that if you are utilizing that, you can minimize the amount of build time, redoing unnecessary work, all these things. You can skip that entire part, everything gets much faster. And you can do things like, okay, so I'm going to start off by creating the jar file in one step, and then I'm going to start with another completely different tiny base image, push my application into that one, and run that one in production, so that you don't expose more things from your container than you need to do to the end users.
And the footprint is smaller as well, right? Because this whole slide could have been a separate presentation as well. Would love to talk to you about all this kind of stuff, all these hacks and tricks, so you can optimize your, for example, Maven builds. So whenever you build a container with, application in a container using Maven, you don't have to download internet every time you do that. So you can just do it once. It's very, very convenient, especially on the hotel networks and stuff. I did that yesterday. It was fun. Actually, hotel networks are actually getting a lot better. I have to say that. You don't have to do hotspots anymore on your mobile phone and use up all your data for a month for one build. But all these kind of things could have been a different talks in itself. But the idea is, now we want to talk about modern Java applications. We want to mention those things to you, to keep it in the back of your head, to think about those things when you really need to do that.
And hopefully we'll be able to show an example towards the end of the talk with a Docker file we have created where we utilize those aspects, all of them.
All right.
So let's head up.
So now, what do we do now? We have something running, we have something with the REST interface, we have containerized that. We need to put it, we kind of need to make it available. In old days, you would put it on the servers somewhere in a basement. Now you call that thing a cloud, so it can be private cloud, public cloud, whatever kind of cloud, but the cloud. And you want to make it available there, so you don't really want to think about managing all those servers. How do you do that? And there are a few things that you really need to think about, and generally in modern kind of development is, first of all, you really automate your builds. That's like a 101. You start with automating your builds. You do not deploy to the cloud manually. You do not use ClickOps. You do not do all these kind of things. But then when you've done that, you need to sit down and think, what else can I automate? And there is a bunch of things you can automate. You can automate creation of your environments. You can automate a lot of different other tests. You can automate a bunch of things. And you really need to do that. This is what it is about the modern kind of development. So we talk a little bit here about automating your builds, but there is a lot of other things, like at least your environments, Pulumi, Terraform, all those kind of things. Use that to create and tear down your environments, to create all the things around your application as well. Do not do what you see on the screen there, using web interfaces on the specific platform, using ClickOps. We've done it, so you don't have to do it.
Yeah. So what you see on this slide is what you need to, in order to, okay, whenever I do git push on this project, I want the application to be rebuilt. I want a new container with my latest changes, so that one in the next step can be made available. And we've decided you can do this like using things like Jenkins, GitHub Actions, Azure DevOps, whatever build technology floats your boat. We've chosen to go for a Google Cloud build for this talk. We needed to do it somewhere, and that's a decent implementation of a build tool.
So generally, you would expect to see something that you're using, whatever platform you're using, they would have their own specific for that platform build tool, and there will be more generic tools with plugins and everything and integrations to all those kind of things. You can pick and choose which one you want, which one is more which one is better for your use. But typically the local one-stop shop kind of builds would be better for specific for that platform stuff. Generic stuff will be, generic stuff, so it will be better for more things, but maybe a little bit worse of being like master of all things.
Yeah. So like the things worth pointing out here is that whenever I push, it starts a new build, and it does that using a cloud build, as you can see on the lower checkbox here. And we specify a YAML file. And you could try to use your Docker file here so that you don't need a specific build file. Try that. If it works, it's great. If not, you can use like a vendor-specific YAML file typically, or Jenkins file or whatever file, saying that, OK, this is how I want you to do my build. So we could talk a lot about that later on, but not today. OK, so that's it. We have made our business logic.
Yes.
We have put that on an application server or a runtime, so it can be run several times by different users. We have also put them into container, so it can be run anywhere. And now we have actually built that container in the cloud. Now what?
We're done, right? We can go home.
Yeah, except for the one downside that no user can access it. It's not available. So
sucks.
Yeah.
All right, but well, actually, we want to have app. We don't really. We want still. You remember, we want to have fun. We want to write code. Running your servers and managing your application is, I don't know. I mean, some of us think it's fun and it's totally cool. You know, sometimes you don't want to do that all the time. You want to actually write some code, write some more stuff. And you know, serverless is a kind of good way of doing that. If you can do that, try doing that, because you do not need. I mean, most of us are not big companies, like big companies that have thousands and millions of billions of containers being destroyed and created every second, and you know, we don't have that. We don't need 3-node cluster of Kubernetes running on your own Raspberry Pi at home, melting kind of through the table. You don't need that. You can actually go serverless. You can also go serverless on a specific platform, but you can also go on-prem as well. So serverless doesn't really mean you don't have servers. Obviously, you need those, but it's more, I like to call it manageless. And manageless version of the thing that we used for our platform is called Cloud Run. So Cloud Run is kind of based on Knative project that is an open source project that is built on top of Kubernetes and a service mesh. It used to be just Istio, now it's more, so that's why I'm saying a service mesh. And on top of that as well, so you can just deploy and drop your application and tell it, well, you know what, fix things for me. When users come in, scale up. When users are not there, scale down. If there is no users at all, just go to 0, go to sleep, whatever. I'm happy with all that. And that is what serverless actually means. So you don't really have to spend time managing it. You don't have to make sure that it's enough resources and all that. You don't really need to make sure that your application is happy and running all the time, because something will check it. And if it gets sick or hanging or something, it will just kill that Docker container and just start another one. And all these kind of things are really, really nice to have. And you can also do traffic splitting. You can, as you can see, you can see the top one, the green one, actually accepts 100% of traffic, but it doesn't have to be like that. You can actually do new version, and you also do traffic routing as well. This is what you can expect from a serverless platform like this or similar. Like Knative can do that as well. So you can do traffic splitting, you can do A/B testing, you can do blue-green deployments, you can do all kind of fun things, and that is fun. All right. Anything else do we want to say on this slide?
I think we'll show it live later on. So
okay.
So there we are.
So now the URL changed. Now it's not localhost anymore. Now it's something very mystic. But that is what you get. Automatic generated URLs are fun, and they are ugly. But you know, this is how it is. Random strings was the name of the project, and that's why it's there, and the rest is just automatically generated. When I came up with that name, I thought it was a really good idea because, you know, random strings is really cool. The thing I didn't realize is that D is, if you look at the keyboard, D and S are very close to each other. So I did a few typos, and I almost created another side project that's probably not as fun. Ransom strings, we're not
going there today.
No, not today, that's for later.
So serverless is a great thing, right? If you have if you are in a setting where you have varying amount of users, or like you create something for users in Europe, you could expect the traffic to be much higher during the day than during the night, for instance. Or if you have changing amount of users and so on, serverless tends to be great. But there are some consequences of running serverless, which are kind of features and downsides at the same time. The one is that, okay, whenever you get more users, it automatically starts another instances of your application, which means in turn that it should start fast, right? Or else your users would be waiting. So yeah, might be suitable, might not. And the other one is like, if you have things like shared cache, distributed cache between your instances, lots of state, then that obviously needs to be synchronized and kept in touch between the instances. And that takes time and doesn't necessarily scale well when your application servers go up and down.
And so, because like so far we've said like kind of things that you might have heard before, like, oh well, you put in container, you deploy it, blah blah blah. You put it in cloud. Everybody's trying to sell you cloud. Serverless. Everybody tried to tell you some kind of serverless. But when you should not do that. And this isn't it. Now you really need to think like, where do we need the serverless, where we can use it. And most of the times, if you have a state, the rule of thumb is like probably you need to think again if you need serverless. But there are offerings that actually do state as well on serverless. So and then you can also do a lot of other things. But what you need to think is what happens when you use serverless. So when you use it, there is a scaling thing, right? There is something going down, maybe to 0, maybe to 1, minimum instance, number of minimum instances, whatever you set it to be. And then there is a scaling thing. And scaling things means new containers. And that means a startup time. That means cold starts. That means something needs to be pulled down from somewhere, started, looked up, deployed somewhere. All those things have to happen, and they really have to happen fast. And this is what it's all about. Now you have done all that. Now you have to make it fast. Because back in the old days, you would deploy things on application servers and let it run there. And then you would have, I did that. I mean, I'm guilty as charged. I have done that. We had an application that would run on Tomcat on a Linux machine somewhere in the basement, and then for a customer, and then the first start would be really slow, but you would just go in yourself, go into URL, it would do the cold start, load everything in the memory, it would be really fun. Then it had a memory leak, then we realized, oh well, we'll just have a cron job that will restart it every Sunday because there is no users on Sunday. And then you realize that customers complain because on Monday it's slow to start, and then you're like, okay, we'll just add another cron job that will ping it on Monday morning, so everybody's happy and the application is warm and fuzzy. But it doesn't work like that anymore. You cannot do that with serverless, so you really need to make it fast. And to make it fast, you really need to think about your application first, of course. How do you do that? Do you initialize and load everything at the same time and everything? But it's not enough. You need to think about things like runtimes. And runtimes, they're all like snowflakes. They're all a little bit different, and they're all a little bit special.
And they have different weaknesses and strengths and so on. So we showed you a list of the MicroProfile implementations earlier on. So the one we're going to talk a little bit more specifically about is Quarkus. Quarkus started a couple of years ago from Red Hat. They started as a runtime intended to be running inside a container. That means that things like you typically need to be open for as a Java runtime with things changing dynamically and beans dropping in runtime and the environment around your application constantly changing. Things like that are not applicable anymore because you know that the application is going to be run inside of this container, which is specified and boxed like this. And in Quarkus, they took the consequences from that and making lots of the choices and lots of the things typically done at runtime, they move that into build time. So whenever you build your application, you do a lot. Quarkus does a lot of work, making the build time a bit longer. But that means that whenever you start the application, it starts really fast because it does the minimal amount of required work.
And we as developers kind of love a bit slow times because we can slack off and do all the fun things, at least if you believe all the comic strips out there on the internet. But the idea is it's okay to spend a little bit more time because it usually happens on CI/CD pipeline somewhere or things like that. But your users will not suffer. They will get answers really, really, really fast. And also it has a bunch of integrations with all the other things that you might want to be using. I mean, you might probably recognize a few logos there. There is like Kubernetes, Camel, Kafka, OpenShift. What is there else? Spring and blah and all this. How do we migrate? I mean, what does it? Okay, fine. We have developed our application. We put it on some kind of app server, maybe not to Quarkus to begin with. But what if we want to migrate? It's pretty easy, right?
Yeah, this is a pretty cool part because you see on this list the entire thing of list of things you need to do to try and switch from one of the other app servers we talked about earlier today and into Quarkus. And you can see there are config files, Docker files, build files, properties files, all these things. What you don't see on this slide is the cool thing. You don't see any traces of any code. No changes to the Java code whatsoever. It's really cool.
So now we are. So now we have a URL. I mean, proper URL, like web URL at least. Our application is running. Everything is happy. We even containerized it, put it in the cloud, put it on a serverless application. What do we do now? What do we want to make? What do we want to do? Because, well, we want to make it even faster. And how you do that? Well, you put 2 more racing cars. Like you add, you multiply the number of racing cars behind word faster, and it goes faster, right?
Yeah, because we already told you, like, well, Quarkus starts really fast, which is true, but it's not fast enough if you want it to be, say, a backend for front-end, which is a typical use case in our case. So what we do then, we want it to run even faster, and then we throw in some additional technology. So Quarkus can be run in 2 ways. You can run it inside the JVM, like the regular way of doing it, which you typically would do on a local machine. But you could also run it in what's called Quarkus native. And that is, it's compiled into a native binary, which can be run directly. And it's using GraalVM under the hood to do that, which is even more trade-off, because it means that your application starts crazy fast. We'll show you in a couple of minutes.
We'll show you in a second. If you're quick enough to finish with the slides, we'll have some time for demo as well. Yep. But the point is, you compile it down to binaries, and then you just run binaries on kind of bare metal kind of thing, and it goes fast. Yeah. And then we're actually done, right? Now we actually have an application that is modern, containerized, all that, running in the cloud. And I mean, again, by cloud, I mean it can be private cloud. It can be, your own stuff. It can be hybrid cloud. It can be public cloud. Whatever floats your boat. But it runs in the cloud. It runs on the serverless, so you can actually share resources. So on your on-prem solution, that means that you'll probably share resources and save money by not buying too much hardware that you can actually share between different applications. In a cloud, that also means that your credit card will go a little bit less warm, or I mean not warm at all, because your application will scale down, and maybe you will be even within like free tier or something of whatever they have to offer. So the questions are just a reminder that there is a questions here. And you can ask questions and all that. We'll do that very soon, but maybe should do a little bit of presentation demo first.
I think we'll do like 3 minutes of demo. Then
3 minutes of demo.
Yeah. So everything we'll be talking about is in GitHub, by the way. And
take a picture of that screen if you want.
Yeah.
It's on the code that we talked about. This whole application is on my GitHub profile. Mats also has a Quarkus multi-stage example where you can build, or we can look how to build a multi-stage, do multi-stage builds. Multi-stage builds. That's kind of a weird thing to say.
Yeah, that's the slide. So let's actually see how this works.
Zoom in a little bit. Do Command plus, I think.
Okay. Yeah, I'm zooming in.
There you go.
Okay. Yeah. Okay. So here we are on Cloud Run with the live version. You see like some metrics and so on. We tested it a little bit earlier today, so that's where you see the spike. So what I'm going to show you now is what this actually looks like if you're invoking it, and this is the regular Quarkus one.
JVM mode.
JVM mode. Yeah. Okay. So now I push enter, you can see that, okay, you are an end user, you're waiting for a result. Okay, what's happening? There it is.
Like 4 seconds or so, right? And there's a lot of things happened in those 4 seconds, right? There is a Google, somebody at Google woke up, the little minions that they have in the data centers. Somebody woke up, run to the container registry, pulled the container, put it on another machine, kicked some other minions to start the machine, and that machine started. Then the application started. Then the HTTP request was routed to that thing, processed, returned. There's a lot of things happening in those 4 seconds, right? A lot of minions doing a lot of work. But now we have native mode, like binary minions.
So I'm copying the URL. I'm doing the same invocation. As an end user, I would be much more happy with this. So this is like from total cold start, nothing's running at all. I just invoked it. You could see it as I did it. And everything started up. And the entire process that Rustam talked about just happened in so short time that I'm still patient.
Still, I mean, you don't know if it was a cold start. It could have been just a regular start as well. And that is kind of a cool thing. Well, you can always say that our application is super simple, it's super easy and all that. But, the whole point is to show you that you have, like, I don't know, you cut your time in like 2 or 3 just by changing the way you compile and do things. So even if your application is really heavy and all that, it will be a little bit different. So you need to think about making your application easy to start and not to load everything and in memory at the same time. So you really need to think about that, but platform also matters.
Okay, so just a really short detour, but we talked about like native or multi-stage builds in Docker, which you could typically do. If you want to do native, you want to build the application inside your container because it's actually tailored towards the environment you're running it in. So that means that, well, you need to do some specific config in the cloud build. You need to do some specific things in the Docker file. Things like, well, here you start from JDK. You actually compile the code to native mode. Then you build the native image, which you can see here. So Mandrel, that's like the Red Hat build of Graal VM, or like on top of it, so to say. You do like the native image command, actually it's Graal VM thing, makes the native binary, and then you actually run the binary. Which we could talk a lot more about, but I think we have 4 minutes for questions.
We do a little bit of questions, but before we switch to the questions, I want to show you the beginning of this. If you wonder what's happening here, why do you copy POM files twice and all this kind of stuff? That's a kind of the fun shenanigans you have to do, so not to download internet twice. At least one of the tricks. But we can talk about that offline. It looks a bit weird, but when you actually understand what's happening, you're like, ha, that was smart.
Yeah, because like the libraries you're using are probably changing less often than your code. So that's we download the libraries first, and then you do your code layer things in container.
Your inner geek gets really, really happy. Okay.
Okay. Yeah. Great. So you're asking the. Okay. So let's start with Spring Boot because there are several questions on that. Yes, it's in many senses it's comparable in the sense that it's. Well, the MicroProfile implementations are runtimes, which you do things like dependency injection, REST endpoints, and so on, which is much the same thing that Spring Boot does. I would say the major difference is that Spring Boot is made by and developed by and maintained by Pivotal used to be no part of VMware, which are doing a great job. But like Spring Boot is one implementation, whereas MicroProfile is a set of specifications. That means that if you, for some reason, happen to want to switch your Spring Boot server application, or like to replace Spring Boot, I don't know how to do that. If you want to replace your MicroProfile implementation, then you can switch to another one.
And the other thing is also that if you want to do it in a Spring Boot way, you're totally fine because you have to learn how to do it, and it will be specific to that. Yeah, with MicroProfile, you will recognize a lot of things, and you will see the same things you're used to doing in Java EE, J2 EE, Jakarta EE. There's different names for all that thing throughout the years, but pretty much the same kind of way of doing that with annotations and all that you recognize. So yes, there is another question very, very similar. Do we need MicroProfile who have Spring Boot? Well, yes, because it's an alternative. There is also Micronaut. There is another ones. There is a bunch of different that you can pick and choose. So our idea is to show you what to look for. But all what we've shown here, you could have done in Spring Boot as well. And and it would still be a modern, fine, nice application. But we were more trying to explain what things you should look for in an application, what things you should add into application, because what you usually do is you take your monolith, elephant of a monolith, you shove it into a tiny little container, and you kind of, barely manage to close the door, and you're like, hey, we're modern, we're done. We're going to put that little huge container on a 3-node cluster of Kubernetes. We're going to have 3 users coming in once in a year. We're done. And this is not really modern stuff. This is what I see a lot at different places, and this is what we're trying to make you avoid.
Yeah. Okay. So is GraalVM free to use in production? Hopefully. There's a free version.
Check the licensing. There are 2 different ways of doing that, but yes, yes, you can.
Yeah. So and also Alina from the GraalVM team is coming this afternoon, and she'll be here tomorrow and Friday. So ask her about those kind of things.
Yeah. So she'll be doing talk tomorrow about that as well. So you're more than welcome to join her talk and ask her those questions as well.
Yeah.
But yeah, short answer is yes.
Yeah. So I think we'll have time to answer the next one briefly. If you run your apps on-prem OpenShift, are we ready to run the same apps in Google Cloud? I think so. I think like the apps themselves, you shouldn't really have to do much with them, but like things like firewalls and configuration and all these things might be more.
OpenShift is a little bit of nicer package than padded version of Kubernetes. So there is a lot of things you can do in OpenShift where you most likely will be able to do in Kubernetes. So yes, you can. And then also you can, if you're containerized it right and everything, you can pretty much move it to whatever you want. Anything that does containers. But again, OpenShift is not really serverless. It is Kubernetes.
Yeah.
All right,
so
we're out of time, I think.
We're out of time. Yeah. So that means that 2 of you, with the questions we already asked, you're anonymous, so we don't know who you are, but please come down.
We have one L and one XL in European sizes. So L and XL, come and get your hoodies.
Yeah, and by that, I think it's time for us to say thank you, everyone.
Thank you very much. Find us on Twitter, follow us, and ping us